Okay, let's look at this question. This question is for homework number 3, problem number 1. There's a bar here. And let's read the question. It is known that a force with a moment 7,840 pound-inch. So this is the moment. About D is required. This is D. The moment around D is 7,840 pound per inch is required to straighten the fence post CD. So you have the fence post CD. This is the fence CD. You want to straighten. So there is a moment to straighten the force. The moment to straighten the fence post CD. If A is 8 inch, this A is 8 inch. This distance from here down to point D, it's 8 inch. And B is 35. This is B. The vertical distance. Remember, this post is with an angle, a little bit with an angle. So B is 35 inch. And D from point E to point D is 112 inch. Determine the tension that must be developed in the cable of winch puller AB. So he wants to know the tension in this cable to create the required moment about point D. So he gave you the moment at point D, and he wants to know the tension that must be developed in this cable. Well, let's try to analyze it using this. So we have B 35, and we have 8 inch, and we have 112 inch, and we have the cable. So he gave you the moment at this point, 7,840 pound-inch, and he gave you A, he gave you B, and he gave you D. Now, let's start solving this. Let's take point C. But point C, you can see that there is one force, the tension, here. And you could analyze this tension has one force in the X and one force in the Y. So, this tension, let's look at it at point C. This is the tension. You can see that this is the bar CD. This is the bar CD. And this is the tension. And this tension is, let's call it force F. And let's call this one angle theta. Let's call this angle. This angle it make with the x-axis angle theta. So this is the force F. This is Fx, angle theta, and this is Fy, vertical, and this is the bar CD. Now, since you have the triangle F, Fx, Fy, let's just do it like here. Fx, and this is F, and of course Fy is here, or just Fy is here. It should be the same. It should be a complete the triangle. Now, this is the angle theta. Now, let's find this distance. What is this distance? What is Fx? And what is this distance? So let's go back to the figure. Remember, Fy, you should have a 35 inch, and the whole force here should have a y, an x-axis 8 plus 112. So this is in the y-axis 35, and in the x-axis I'm taking the whole triangle. Okay, so this is 35 inch. I'm gonna put it here, 35 inch. This y-axis. I'm gonna put the x-axis from here, 8 plus 112. So this is the x-axis. So okay. So 8 plus 112 is 120. So this is the x, and this is the y. So now we could find the angle. Remember, tan theta is equal Fy over Fx. Fy over Fx. Fy is B. And Fx is what? A plus D. Right? A plus D. So 35 over 120. 8 plus 112, 120. You'll get 0.292. You just go plug it into your calculator and find tan inverse of that to find the theta. Theta would be equal 16.26. Which means that the angle, this force with the x-axis is 16.26. Once we find this, we could find Fx. Because Fx is F cosine theta. Look at the angle. F cosine theta is fx. So f is unknown. Cosine 16.26 is equal 0.96 f. Remember, fx is going that way. Okay? And if y is equal, if fx is equal f cosine theta, fy will be f sine theta. So f sine theta, f sine 16.26, so it's 0.28 f. And it's going, look at this, it's going downward. So it's gonna go downward. So now we have fx and fy. Let's go ahead and look at the moment. Now we want to find out, remember the moment? Now we have the forces in the x and in the y, but we have this moment. So let's look at this moment. Remember, we're gonna assume that the moment, if it's gonna go clockwise, it's negative. If it's going counterclockwise, it's positive. So now, let's look at point C to D. So let's look at point C to D. Point C has an Fy and point C has an Fx. So remember, Fy, Fx, and we have Fy is equal 0.28f. So 0.28f and Fx 0.96f. 0.96f, and this is the directions. Remember, this is C and D. Let's take moment at D. Okay, because we have the moment at D. Okay? So, what we're going to do it like this is, first of all, let's say if there is a nail at point D, this will push it that way. This will push the whole beam or the whole bar that way, which is going to be what? Counterclockwise. 0.96, and this is the perpendicular distance between C and D. It's like, this is the force like this. The perpendicular distance, the vertical distance is 35 inch. Remember 35 inch? 35 inch. Remember 35 inch? 35 inch. Okay? So, 0.96f times 35. That's in the positive. And how about this one? This is going to take the bar. If you have a nail at point D, this is going to push it clockwise. Clockwise means negative. Minus 0.28f times, what is the perpendicular distance between the force and point D? It's like this. What is that? Let's look at the force and D. So this is the force here, and to point D, you can see it's 8 inch. So this is times 8. So this is the moment at D, 31.36, if you just add them up together, 31.36 F, and it's going to be in the positive, so it's going to be like that, bound inch. So now, the force, the moment was given 7840, so this is equal 7840, 31.36 F equals 7,840. So now we could find the force by dividing this by this. You'll end up with force equal to 250 pounds. So the force that is needed by this tension to make the moment at point D 7,840 pounds per inch is equivalent to 250 pounds. Thank you.